Hi everyone. So in the previous videos, we have discussed these three questions from the stack important interview questions. Today we will discuss the fourth question, which is largest rectangular area in a histogram. So what this question is all about, let us go through the problem statement first of all. So in this, what we will have one input array which denotes the height of the bar, you can say. So for example, 2 1 5 6 2 3, this is the input array. So you can see this 2 is the height, this is 1 is the next bar height, and then 5 6 2 and 3. What we need to find out, we need to find out the rectangle area. Okay, we so here you can see we can form multiple rectangle. For example, rectangle of length 2 by 1, rectangle of length 1 by 6, and okay, rectangle of length 2 by 2, okay, 5 by 2. So this way we can create multiple rectangle. Now you need to print the rectangle which is giving the maximum area. So what is the maximum area which we can obtain from this given heights? For example, here we can achieve this 5 cross 2. Here we will just draw a line, and you can see the width is 2 and height is 5. So the area will be 5 multiplied by 2, which is 10. So we just need to print the maximum area which we can get from this particular height array. All right. So what is the first approach which is coming to your mind? Just pause the video and think about the solution, how we can get the rectangle of having the maximum area. So the first approach which is coming to my mind is what I need to do here. Here, let us check from the diagram. If I want to get the rectangle, okay, at particular index I, let's say. So if the previous element is smaller than me, it means I cannot form a rectangle with previous element. If next element is greater than current element, it means I can form the rectangle with the next element. Then just go to the next element and check. Here we can see for 5, 2 is smaller than 5. And for 5, 1 is smaller than 5. So you just need to get the right side first smaller element and left side first smaller element. Once you got these two elements, you need to take the difference of the index minus 1 multiply with the current height will give you the area. For example, here, okay, index of 2 is nothing but 0 1 2 3 4. All right, 4, and index of 1 is 1. So the maximum area which we can get at the index, this particular third index, is nothing but 4 minus 1 multiply with 5. So 2 multiply with 5, which will give you 10. Similarly, we can get the different rectangle area, but we want to print the maximum one. So the approach is nothing but it is very simple. So what we are doing is, for each bar, what we want the first bar in the left side, which is smaller than the current element. Let's say index of that element is left index. Now, for each element, I want to get first bar in the right side, which is smaller than the current element. Let's say this is known as the right index. Now we will calculate the distance or the length of the rectangle, which will be nothing but right index minus left index minus 1. Rectangle area, we know height multiplied with the width. So height is nothing but current bar height multiplied with the width. This will give you area. Now there are some corner case here we need to handle. Let's say if left index is not found. What it means, there is no bar in the left side which is smaller than the current element. Now here there are two more cases. If right index found, simply distance will be nothing but right index. If right index also not found, the distance will be length. It means all the elements in my left side and all the elements in my right side are greater than my current height. So I can form the rectangle with the full length array, right? If right index is not found, what it means, there is no bar in the right side which is smaller than the current element. Again, we'll apply the same logic. If left index found, distance will be nothing but length minus left index minus 1. And if left index also not found, this case we already covered here. This is same as the case 2 of this particular case. So this is the simple logic. All right. Let us quickly jump to the coding part. So here I have written the code. Okay, let me just comment out the stack part one. So what we are doing for each bar. Okay, so for each element, I will calculate the left index. I will go towards left side, and if I will get the first height which is smaller than the current height, and we will update the left index here. Similarly, I will get the right index here. I will go towards right side, and once I got the first height which is smaller than the current height, just update the right index and come out of the loop. Once we got left index, right index, we need to apply the logic. If left index is not found, right index also not found, that means distance is nothing but length. If left index not found, right index found, then the distance will be nothing but right index itself. Or if both are not found, okay, if we are coming to this condition, it means left index is there, but right index we are not sure. Just apply the condition on the right index and you will get, if right index is -1, then the distance will be nothing but length of the array minus left index minus 1. If both are not found, if both found, left index is also not -1, right index also not -1, that means both found, then the distance will be simply right index minus left index minus 1. And how we will calculate the area? Distance multiplied with the height. And there is one variable I have taken which will store the maximum area. So maximum area will be equals to max of max area multiplied with the current, and just compare with the current area. This way we will get the maximum area and we will print it out. So let us quickly run this code. You can see here we are getting maximum area as 10, okay, which is nothing but we have seen here 5 multiplied with 2, which will give you 10. Now we will, so time complexity of this algorithm. Since here you are seeing that we are running 2 loops. There is one outer loop, and for each index, we are running one more loop to get the left index and the right index. So loop inside loop will give you the time complexity as O of n square. All right. So, and we are not using extra memory. So space complexity is nothing but constant, and the time complexity is O of n square. So let us think about how can we optimize this approach. So pause the video and think about how you can optimize this problem. So let me start with the second optimized solution, which is with the help of stack, we can optimize it. Okay. So what I will do in the stack, I will take one stack. In the stack, you just need to insert the element into the increasing order. If you found, so step 1 is nothing but insert the element into the stack in increasing order. Okay. Step 2, if let's say your current element which you want to insert is not greater than the top, it means increasing order is not there. Okay. You need to pop the element from the stack until you get the current element is greater than the top of the stack. Okay. So very simple. You need to insert the element into the stack in increasing order. If you found that current element is not greater than the top of the stack, you need to pop the element from the stack until you met the first condition, which should be increasing order, right? Now, very important here, when you are popping the element, okay, so while popping out the element from the stack, you need to calculate the area for the popped element. Now, how to get the area? Okay, how to get the area, which is very 1 second. Yeah. So how this approach is working? How to get the area is very easy to understand. Do not worry about that. So what I told you, 1 second, something is wrong with the slide. Okay, yeah. So do not worry. So what we have done in the brute force approach, for each element, for each index, you want the first height in the left side, which is smaller, right? Then we got the left index. In the right side, first height in the right side, which is smaller. Then we got the right index. Once we got these two indexes, that means we can easily get the maximum area, right? Now with the help of stack, okay, since what I told you, here we are inserting the element into the increasing order, okay? It means if current element, if we are popping some element from this stack, we are sure that the previous element, after popping out the element from the stack, the top element in the stack will definitely be smaller than the current element. Why? Because we have pushed element into the stack in increasing order. So left index will be nothing but top of the stack. Understood? Right? Now let's talk about the right index. What is right index? Right index is nothing but the first height in the right side, which is smaller. Now, when we are popping the element from this stack, tell me, we are popping the element from this stack when current element is smaller than the top. It means it is the height which is smaller than the popped element. So index of the current element is nothing but the right index. All right, we got these two, left index and the right index. Then we will apply the same logic which we have written here, this one. All right, and we are good to go. Now, very good thing about this approach is here we are just running one loop, because here left index and right index we are getting in the constant time. So no need to run a loop again. So the time complexity of this approach will be of n, and the space complexity of this approach is also n, because we are using a stack to store the element. All right. Now let us quickly jump to the coding part. So here, what we need to do? Okay, first of all, we will define one stack and just run the loop on the element or on all the element of the array. Now, if you are getting the element first time, it means your stack is empty. Just push the element into the stack. Second time, let's say you have some element into the stack. What you need to check, because we are saying we will insert the element into this stack if the current element is greater, because we want to follow the increasing order. So if you found out, hey, your current element is not greater than, then we will pop the element from the stack. This is the popped element. All right. Now, once we pop the element, we need to get the area which we can form with the current height, with the popped element height. So I told you very easy that this I is nothing but the right index. This stack top is nothing but the left index. And this is the -1, which is exactly same as the logic which we have written previously. This is same as this one, right? If stack is empty, then we know that we are not able to see the left index here. So answer will be simply right index. All right. This way we are able to get the maximum area. So maximum area will be nothing but maximum of previous maximum area and distance multiplied with the current popped element height. All right. Once we are out of this loop, it means there are two possibilities. Either stack is empty, just push the current element into the stack, or next element is greater than the top of the stack, so we need to push the element into the stack. And one very important thing here is we are not pushing the element, we are pushing the index of the element. So once we will come out of the loop, we need to pop the element from the stack if there are any. While popping out, again we need to apply the same logic. Popped index will calculate the distance and we will get the maximum area. We need to print the maximum area, right? I hope it is easy to understand. If you feel anything is not clear, let me know. Please comment out. or you can rewatch the video if something is not clear. Let me run the code. You can see this is the first brute force approach. We got 10. With the help of stack approach, we are getting 10 as well. And here we have improved the time complexity also. And space complexity we have increased actually. Instead of reducing, we have increased it. But yeah, so this is all about this approach. If you feel anything is not clear, please comment out. In the next video, we will discuss about the fifth question from this stack, which is design a stack that supports retrieving the minimum element into the constant time. So these are the 5 questions from stack I picked, which are very, very important for the interview. If you are able to solve all these 5 questions, you will be able to solve maximum questions from the stack, because these 5 questions are key of the stack. In every question, we know what is the power of stack, how we can use the stack. All right. So thank you, everyone. If you like my content, please like, share, subscribe.